times I. So let's get into our modeling with equations. Like I said, it's going to be word problems. Now, as always, I'm probably going to be a little fancier and go through all the steps to solve these word problems, like, define the variable. I'm going to do all of that. You'll probably have a little less work than I do. So I know this looks crazy here today, and we're not doing all of it today. Notice it said 17A. There is a B part to it. We're going to save that for Monday. Today actually isn't too bad. We're kind of doing the top 3 ones. Making and using models, aka writing an equation. Okay, problems about interest. So we're going to have some percents today. So you might want your calculators out for that. Nobody wants to do decimal work in their head, I don't think. And then kind of like I said, we're going to have some throwbacks to geo with some area, etc. Different things like that. So grab your calculators. Now, I know this looks crazy. I know hardly we all go through all this crazy stuff to solve a word problem. Of course, I'm going to do that today. So first up, of course, identify the variable, step 1. So that just means you're recognizing what you're solving for. I'm solving for the width of a rectangle. W equals width. That's all that amounts to. Translate the words to algebra. So, this is my favorite. Read each sentence. Read the problem, and of course try to translate that and make it into an algebraic equation. That's what we're going to have today. We're going to set up our equation. We're going to solve our equation. Who would have thought? And I'm sure, as always, we all check our answers. Okay, so a couple of things on the check our answers. I know you don't plug it in. Very few people do. But today, since we're doing word problems, we want to make sure that our answers are applicable to the problem. Meaning, maybe your equation boils down to a quadratic and you have a positive and a negative answer. Are you going to use the negative if you're solving for length of a rectangle? No, so you would just reject it. So that's what it really kind of means by check your answers. You want to make sure that they apply to your problem. And of course, word problems, I'm going to label them. All right, here we go. Car rental company charges $30 a day and 15 cents a mile for renting a car. Alyssa rents a car for 2 days. Her bill is $108. How many miles did she drive? So like I said, I'm going to be fancy and go through the steps. I'm going to identify the variable. I'm going to use X, of course. Now, we're trying to figure out how many miles did she drive. So that's what X is representing. Miles. I'm just going to keep it short and sweet. I'm going to say miles driven. Okay. That's all the define the variable part is. Now, if you don't do that, am I going to freak out? No, I'm not going to freak out, but I'm going to define the variable for all of these today. Okay, so her total bill, $108, so I know that's what we're going to equal. Got it. So let's just reread it and see where we're at. So $30 a day, 15 cents a mile, and she's having the car for 2 days. So right off the bat, 30 bucks a day, 2 days, how much money are you in for right now? 60. We know we have $60 into this. And then we have the 15 cents a mile. Well, we don't know how many miles we're driving. That's what we're trying to figure out. I'm going to put 15 cents as a decimal and then times however many miles we're going. So, word problem, not too bad of an equation to solve. We can handle this. I'm going to subtract 60 off of each side. And then divide by 0.15, of course. We got it. And our final answer is, punch it in, what do you got? Somebody, anybody? 320, and I'm going to get fancy and throw a label on it. Miles. Ooh. Got it. So even though we're doing word problems, don't let it scare you. Today, that's like as wild as it's going to get. We might have to factor on one of them, but the equations are not so bad today. Notice I keep saying today. Wait for Monday. Okay, moving on. Let's talk about interest. Now, I don't know how good we are or how much we know about banking, interest, money, etc. So I might have gotten carried away with all of this up here, but I just want to make sure we're clear on all these variables. Remember, most of you probably have savings accounts or something with a bank, I would hope, at this point in time. So remember, you put your money into the savings account, the bank pays you interest, very small interest, like pennies interest to have your money in the bank. Because then they can loan that out for car loans, mortgages, different types of loans, things like that. So of course we are paying, we're going to be talking about simple interest. Now, this vocab word, I didn't know if you knew what principal. principal is how much you are investing in your account at the beginning. So if you're open your savings account with, I don't know, $2,000, $2,000 is your principal. The percentage they're going to give you, which is usually very small in a bank, the percentage they're going to give you is the rate. So if they're going to pay you 2%, that's high, I'm going to put that as a decimal point 0.02. Real shock here, T is of course time, and that's in years. So just recognize if they get crazy and tell you like 6 months, you're not going to use 6, you would use 0.5 or half a year. You're always scaling the time in terms of years. And then of course our little old school I equals PRT formula. Hopefully that looks a little bit familiar to you. So you're calculating the interest, how much money you're going to make off your investment. You multiply the principal, the rate, and the time together, and that tells you how much money you actually make off having your money in the bank. We're all about making money. Okay, Mary, good old Mary, I wish I was Mary, inherits $100,000 and invests in 2 certificates of deposit. One pays 6%. Do you know what a certificate of deposit is? Okay, so it's you invest the money, you can have it in there for a year, 6 months, a certain amount of time. All right, 6%, the other's 4.5%. Those aren't too bad, I guess. Her total interest is $5,025 per year. How much money is invested at each rate? Okay, well, you know I like to define the variables. So we're trying to figure out how much money at each rate. I'm going to use X. I'm sure we're all using X. So doesn't matter which rate you start with. I'm going to start with the 6%. So I'm going to say that's my amount of money. It's 6%. So now we have to figure out an expression at the 4.5%, which I'm going to work on here in a sec. I'm just going to get them labeled. Now, you have a total, remember, Mary inherited, lucky Mary, $100,000. So let me ask you an easy question. If you invest $20,000 at 6%, how much do you have left to do at the 4.5? I heard it, $80,000. If she does $60,000, how much do you have left? 40. And you're coming up with that because you are subtracting it from what? 100,000. So yeah, I'm just going to say it's 100,000, and I'm going to deduct however much you're putting in at the 6%. I don't want to, I mean, could I use a totally different variable? Sure, but I don't want to make it a system and all this complicated, crazy set of equations. We can keep it pretty simple, I think, here. Now, remember our formula. It's on your notes. I'm just going to put it so it's in front of us. And let's see what we can do. So it tells you your Mary's total interest is $5,025. That's pretty good. I like it. So there's our I. Now, for this one though, because we have the 2 different amounts, so I'm thinking about our first amount. So again, I'm trying to figure out the principal for it. I have no idea. I'm going to do X. The rate was 6%. I'm going to put 0.06 next to that here in a second. And then our second rate, which I'm going to add to it, our second amount, that 100,000 minus X. And that rate on that one's the 4.5%, which I'm going to put as a decimal. Got it? Okay. Now notice, and I'm going to throw it on here just for dramatic emphasis. Remember, I've got the P, I've got the R, I left room for the T, but I don't really think we need to write it. Because what's your time frame? I'll put it on there for drama. But I did think about the time. It's annually. I don't know if we necessarily need the 1, obviously. Okay, let's solve it. I'm going to ignore the 1, clearly. This just kind of irritates me. I like the number first, the coefficient first. I'm just going to flip it for right now, 0.06x. Who needs the 1? Let's distribute this through. So we're going to have to figure out what is 100,000. I don't know why I have an X on here, just 0.05. Am I right? Sorry, guys. Writing and talking. What's 0.045 times 100,000? You got it, 4,500. And then minus 0.045x. And that really, that's not too bad of an equation to solve. Of course, we're going to put our terms together. I'm going to subtract the 4,500 off. I'm just going to do it. You get 525 when you subtract it. 0.06 minus 0.045, 0.015. running out of room. Divide that out. What do you got for x? I heard it. 30. Divide it. What do you got?
35,000.
You got it. 35,000. Now, you know, I like to label. That was our amount at 6%. Circle that. I'm going to put my second answer up top just because I'm running out of room. Okay, if you did 35,000 at 6%, what's 100,000 minus 35,000? Yeah, so there's my other amount. I'm just running out of room, so I'm going to throw it up top here. And that was at the 4.5%. Got it. So anytime you have anything with percentages today, think about using that I equals PRT, the principal rate times the time. We just, because we have the two amounts, that's the reason we have the two terms here that we added them together. That's as wild as the money gets. Hey, let's talk some geometry, right? Dimensions of a garden. A square garden. Boy, this is a lot. I copied a little bit gray on yours, but I think you can still see everything. A square garden has a walkway 3 feet wide, and it's around its outer edge, as you can see it. Mine's in green, clearly yours is not. Hopefully you can see that okay. Shown in figure 1. If the area of the entire garden, including the walkway, is 18,000 feet squared, what are the dimensions of the planted area? Okay. So, of course, we're trying to find the dimensions of the planted area. You know, I like to define the variable. I'm going to get fancy, and that's what I'm going to say x is. I'm going to say it's the length of the planted area. Now, notice I said length. You could have said width. You could have said the side, because it's a square. Isn't it all the same, the length, the width, the side? However you want to phrase it. I just said length because I don't know, I liked it. So let's talk next up formula. So how do you find the area of a square? There's different versions. I heard base times height, length times width, side times side, side squared, however you want to do it. Now since I use length instead of side or base or height, I'm going to do length times width. And just how you phrase it. Okay, so good news, they tell us the area, so I'm going to fill in the 18,000. And the other good news, the length and the width are both going to be the same because it's a square, right? So whatever I can figure out for an expression for the length, I'm just going to copy it for the width, okay? So now we have to look at the picture though. We are trying to figure out the dimensions. Now notice, oh boy, notice on here, it's just this inside piece is the x. They want the dimensions all the way across, including that sidewalk area, this green perimeter area. So I'm thinking about, okay, so if I have this, of course, my x, it's telling you this is 3, it's telling you this is 3. So I'm just going to write an algebraic expression for that. You would have your 3 feet at the top, my x amount in the middle, and my 3 feet at the bottom. And I'm just going to clean that up and put it as x plus 6. And of course the width is going to be the same because you're going to have the x, the 3, x plus 6. All right. Well, what's your gut instinct tell you? What's your next move? I like what Anu said, and I'm glad. I thought somebody was going to for sure say FOIL. Notice she said square root, which I would do that too. At first thought, I'm like, oh my gosh, I'm going to have to FOIL this. I'm going to set it to 0. Then I'm like, wait a minute. Let's work smarter, not harder, right? I'm going to think of this as squared. And then I'm like, oh, piece of cake. To get x alone, I'm going to get rid of the squaring with a root, and then I'm going to take 6 off. Got it. All right, you definitely need your calculator for that. What is the square root of 18,000? Let's just round it to something nice. I like it. Technically, we should have plus or minus on it, right? Now, I know we have to subtract 6, and we're going to do that in a second. But technically, we should have plus or minus on it, technically. Do I want both the plus and the minus, though, for this very lovely problem containing about garden and a square? No. So I'm just going to use my positive 134. And let's take 6 off. That puts you down to 128. Oh, what are we in feet? Got it. Okay, so it asks you the dimensions of the planted area. So I'm just gonna get fancy because really dimensions, it wants the length and the width. They're both what? 128. So I'm just gonna make it look fancy and I'm gonna say it's 128 feet by 128 feet because it wants both dimensions. Just to make it look nice. So a little geometry, so not too bad. So you could have foiled this together, set it to 0, factored on it, which would have been a lot more time consuming. But luckily it was the squared, so we could root it and make it a little more quick to solve. Any questions on that? Home stretch, another geometry problem, my friends. God, I love geometry. Oh, God, I could draw a picture though. Rectangular building lot is 8 feet longer than it is wide. Area 2,900 feet square. Find the dimensions of the lot. Okay, let's draw a rectangle. My artistic skills I was not blessed with. Now, we are trying to find the dimensions. It tells you the building is 8 feet longer than it is wide. So, you know, I like to define my variables. So we're going to try to find the width. I know that really seems hardly worth writing up there. Again, am I going to get upset if you don't define your variables? No, but you know, that's what I'm going to roll with. So I'm going to just label, of course, width. Now, key here, 8 feet longer than it is wide. So for the length, to figure out the top and bottom, it's going to be the width plus what? 8. Okay. Other keywords in this problem, so many good keywords. Area again, so I'm going to jot down that area formula that we had in the last one. And let's just plug in what we have. So the area is 2,900. Got it. Looking over there, the length, I've got that labeled W plus 8. And of course our width is the width. Now unfortunately no squareds on the right, so I am going to have to distribute and see where that takes me. So I'm going to have my W squared, my 8W. Okay, so we are technically going to get 2 answers. It's quadratic. Before we decide, or my factoring, completing the square quadratic formula, let's set it to 0 and look at it. So I'm going to subtract 2,900 over. Got it. Okay. So from here, of course, you would have the choice. Do you want to factor it, complete the square quadratic formula? Doesn't matter. You'll get the same thing. 2,900 is kind of a large number, clearly. Believe it or not, it does factor. There are 2 numbers that multiply to negative 2,900 and add to 8. This is where I would probably use the table in my calculator to help the cost for 2,900. Remember, in your calculator, go to y equals, and put in negative 2,900 over x. That will give you everything that goes into negative 2,900. And then pull up your table. You're probably going to have to scroll down the table a little bit, like kind of a lot. Ignore any decimal answers. Did you find the numbers? Yeah, 58 and 50, okay? Good deal. And I'm going to make, of course, 58 positive, 58 negative, or 50 negative, sorry, 50. Okay, keyword, get ready for it. What are your 2 potential answers? Yeah. So much drama in math, who would have known? And clearly, which one do I have the issue with? Yeah, hasta la vista. So we're just going to keep our width as 50. And we are in feet. And it wants the dimensions, so let's figure out the length. Well, if we're using the 50 for the width, what's your length? 58, piece of cake. So again, how you solve the equation is up to you. You could, if you were like, man, I don't want to figure out what multiplies to negative 2,900 and adds to 8, you could have used quadratic formula. You'll get the same answers. The choice is you, how you want to solve it. All right, last one. A man who is 6 feet tall. Can you see all these numbers in the picture? Yeah, that's kind of, yeah, hopefully you can. 6 feet tall. There he is down there, kind of the bottom right on your picture. Wishes to find the height of a certain 4-story building. He measures its shadow and finds it to be 28 feet long. That's at the very bottom of the picture there, if you can see it on it. While his own shadow, here, is 3.5 feet long. How tall is the building? So we want to find Can you see it right there, that little H label? I hate when the pictures don't copy that well. So that's what we're trying to find. So how tall is the building? So, you know, H is the height of the building. That's what we're trying to find. Okay. All right. So I think we can make this one pretty easy. Get ready for it. I'm going to use an old school proportion. Remember what a proportion is? Two fractions set equal. And why am I using a proportion? I mean, always about the why. Why am I going to use a proportion? Because you're really comparing two things. I'm comparing the guy's actual height to the shadow. You're comparing the building's actual height to its shadow. So that's how I'm going to set these fractions up. And it doesn't matter if you start with the little guy or the building. I'm going to start with the little guy, okay? So his actual height is 6 feet. And he casts a shadow of 3.5 feet. Just for the sake of ease, I'm going to put 3.5. Now, when I do my second ratio, fraction, comparing two numbers, I want to keep it in the same style, meaning I did the height to the shadow. So when I look at the building, I'm going to do the height, which is H, we're trying to figure out, to the shadow. I don't want that one, I wanted this one. So just make sure you keep everything lined up. Okay, do you remember how to solve a proportion? Cross products, yeah. So we're going to do 6 times 28. I don't really know why I'm writing that. I would just put that in your calculator, of course. H times 3.5. And then you're going to divide off 3.5. Final answer. 48 feet. Got it. Any questions on this? Okay, so those are our